Hello. Hello? Can you hear me? Good. All right. So if you came to Karen and Marlin's talk earlier, you will have seen how they had some problems prompting an LLM to get an image for their slides. I took a different approach. I prompted my daughter for an image of a stochastic parrot. Isn't that awesome? It's great. I didn't have the same problems they had. Prompting my daughter is not, I don't always get the results I expect. There's definitely some problematic non-determinism going on there, but we're working on that, but this parrot is fantastic. So I have a quick disclaimer here. This is actually not the talk that I had in mind when I proposed it for reasons that we'll get into. So this is more of an experience report of what I learned along the way of figuring that out. So up to about 6 months ago, my use of AI had been pretty basic. So I'd made a lot of kind of small applications. I was using it for advice about things that I was working on and rubber ducking. How do I do this? How do I do that? Getting started with unfamiliar tech is something that it's really good at, so I've been using that. But I still didn't really see how I would actually be able to apply this to my work anytime soon. There were lots of stuff was fun, but it didn't seem to be really generally useful. And then, I think maybe about 6 months ago, Claude Sonnet 3.5 came out, and that was a real step change in their ability to generate code in a reliable way. So in our great hierarchy of levels of AI tooling, I'm still just like banging rocks together, basically, at this stage. But then I've had this problem that has been looming over me for some time now and has really become very evident this year, and that problem is Kotlin coroutines. So as a bit of background, I developed Cursive. Cursive is a plugin to IntelliJ. IntelliJ runs on the JVM, and until recently, IntelliJ was millions and millions and millions of lines of Java. And Java has problems, as probably many of us are here because of that. And JetBrains were obviously very heavily invested in the Java ecosystem, and so they developed a new language to replace Java and try and fix their problems, and that language was Kotlin. And you'll hear Kotlin referred to as a better Java, but I actually think that does a bit of a disservice. I think it's actually a much nicer language than that. And Kotlin uses coroutines as its concurrency primitive. And coroutines are really, really nice. So they're a little bit like Java virtual threads, although they're not quite as transparent as that. But you can think of them conceptually as similar to core async, basically. And so this is a screenshot of the IntelliJ documentation. The important bit is at the bottom. Since 2024.1, it is recommended to use the coroutines approach over threads, which is what had been used for all the concurrency stuff previously in IntelliJ. And IntelliJ is an extremely asynchronous system, just for performance reasons, basically. And so the Java doc of lots of APIs that I use are now starting to look like this. JetBrains is basically telling me that a lot of my code is now legacy, right? So right back in the day when I first started working on Cursive, IntelliJ runs on the JVM, so I could use Clojure to do it. It seemed, I was developing Cursive because I wanted to be programming Clojure, so it seemed obvious I should use Clojure to develop Cursive. So I now have 10 years of Clojure code. So Cursive is pretty evenly split. There's about a third it's about 35,000 lines of Java code, which is mostly legacy, obsolete stuff I never touch these days. There's about 35,000 lines of newer Kotlin code, and there's about 35,000 lines of Clojure code as well. And my problem is that JetBrains are now telling me that my Clojure code is obsolete. And again, this is a snapshot straight from the doc. It will be required to use Kotlin, at least partially, for example, to implement coroutine-based extension points. And this is one of the developers in Slack. Kotlin is required more and more, and it will make it to more APIs in the future. There is no way we can express proper structured concurrency and cancellation in Java. So the writing has sort of been on the wall for a while, but and I now have a problem, right? I have 10 years of Clojure code, and I don't want to spend another 10 years rewriting it. Right? And this is where LLMs actually turn out to be amazing, right? So I actually think that code translation might be the secret superpower of LLMs because they're really, really good at it. And there shouldn't really be a surprise. Like the original Attention is All You Need paper, which introduced the transformer architecture, the example that they used was a translation problem. It was translating natural language rather than computer languages, but it's a very similar problem. And they're just astonishingly good at this. And so this is a series of use cases I have. I was going to talk about them. I translated the difflib from Python, which is a diffing and patching thing. I translated that to Clojure so I could use it. So it's not all just a sad tale of there being less Clojure code in the world. This also works in the other direction as well. I've used it a lot. I've been working a lot with AI APIs recently, so I've been using all of the tooling around AI is in Python. So a lot of the client libraries have Pydantic specs for the APIs, and I can just give those to the LLM and it will give me Mali specs back. And these translations are never exactly perfect, but if I had to spitball a number, I'd say they're like 95% of the way there. So when I'm translating code and Clojure code from Cursive into Kotlin, I can translate like a whole namespace of like real functionality, and then I spend anywhere from maybe half an hour to maybe 2 hours fixing it up, and then I'm done. I can get on with my life. And I've also used this for translating IntelliJ code to Clojure. Like sometimes there's something from IntelliJ that I know is there and I would like to use, but maybe I'm like loading it into a REPL, and I don't want to be like compiling Java and passing classes over or whatever. It's just a bit of a faff, so I can just convert it to Clojure and send that instead. And then an interesting use case, I've actually spoken to numerous people at this conference who have real use cases for code translation in their lives. And one of them is Chris Oakman, who presented about there he is over there, who presented about the Clojure standard formatter. Now, Chris, a few years ago, did a really sterling job with par and fur, which some of you may have heard of. And he translated the original JavaScript implementation into I don't know how many languages. Like it was like this Herculean task, and he did it. So props to that. And now he's done the same with Clojure standard formatter. He's got a JavaScript implementation that he wants to translate into Python so it can be used in Sublime, Lua so it can be used in Envim, and translate it into languages so that editors written in those languages can use it. I haven't actually done these last two yet, but I have a potential use. I think it would be really useful for Clojure Dart because there's tons of Dart and Flutter code out there. But Clojure Dart, there's very, very little training data. There's already not much training data for Clojure, but Clojure Dart there's even less. And it's kind of weird. Like Clojure Dart doesn't quite look like Clojure, and that's because it works with Flutter, and Flutter is just a bit weird as well. And the other thing is I would actually like to use the TypeScript types in Cursive to provide better support for NPM dependencies for ClojureScript. And the first step in that process is having a TypeScript parser. And I've been looking into this for a while, and as far as I can tell, there's exactly one TypeScript parser in the world, and that is in the TypeScript compiler. And I've looked at it. It's big, right? It's I don't know how many thousand lines of TypeScript, but it's pretty simple code. It's just a straightforward recursive descent parser. And I think I should be able to translate that into something that I can use in Cursive, like Kotlin probably. So initially I started out doing some experiments with this, and this whole project kicked off after I saw a throwaway comment. I can't remember if it was on Hacker News or Reddit or somewhere saying that LLMs were really good at code translation. I almost didn't even get started because I cut and pasted a bit of code into the web interface, which I was doing at the time, and it didn't work very well, and I was like, oh, this is dumb, you know. But in the end, I read somewhere, again, that the context that you provide to these things for these tasks is really important. And so I thought, okay, well, I can do a little experiment. I'll do like a proof of concept and see if I can make it better. So things I've learned along the way is that for coding tasks using LLMs, context is everything. Like this is kind of the open research area for coding tools in using LLMs. And this might be old news to some of you, but just so we're all working on the same mental model, I just want to talk a little bit about context. So when you interact with an LLM, they have what's called a context window, which is like a fixed size of information that you can send to the LLM. And it's measured in tokens, which are sort of roughly analogous to words, basically. And these things are quite big on the frontier LLMs these days, but it is a fixed length. So there's only so much information you can send to it. And the really important bit with coding tools is, what do I put in here? What is the most important thing that I can put in here for this task that I'm trying to do to make the LLM's performance on that task better? And the thing that was surprising to me when I first started this, I was used to a chat interface, and it has this sort of history where it feels like the LLM remembers what we've been talking about. But it turns out every call to an LLM API is completely stateless, and it just remembers the conversation because every time you talk to the LLM, you send the whole conversation back to it, basically. So when you interact with an LLM, you'll start with a little bit at the beginning. This is your system prompt, and this is where you tell the LLM, you're sort of setting the stage for what the conversation is going to be about and what role the LLM is going to play. So, you know, you're an expert software developer, you're a helpful customer service agent, and a whole bunch of instructions about how to act like that thing, basically. And then you'll have some request in some form, and you'll send it over there, and the LLM will reply. And then you just keep building up that context over more conversations, like this. And each time this API call goes back to the LLM, all of that gets sent back. And this is why you can pick up a conversation with an LLM that you had like a year ago, and it'll be like, oh yeah, I remember we were just talking about that. And that's because it can't tell, right? So when you're using LLMs for coding, the context is quite a bit more complicated, right? So you send the system prompt, but there's a whole bunch of other information you probably want to send along with it. You want to send like a repo summary, a bit of information about the project that you're working in, you know, maybe some documentation. This is the project layout. This is the programming languages we're using. These are the technologies that we're using. This is where everything is. You might want to send some documentation. You know, we're working with these APIs. Here's some documentation about those APIs, whatever form that takes. And you probably want to send the content of some files as well, so that it can work with it, so that it can work with those files. And then you have your conversation on top of that, everything. And it's very easy with a larger project to fill that context window up very, very fast. And then you have tricky choices about how do I optimize what I put in there. And the other thing I've learned is that prompts are really important, which again, in retrospect, is not a surprise, but at the time I didn't fully appreciate it. So this is the interface of Claude's artifacts. So if you haven't used it, so this is the web interface. So Claude is made by Anthropic, which is kind of OpenAI's probably main competitor. And so they have this web interface like ChatGPT, but you can say, build me a website, and it will build the website, and it will open it up in a side panel in an iframe. And it works. I mean, it's running right there. You can interact with it, you can play with it. And if it's not doing what you want in the chat, you just say, hey, can you fix this up and make this do this thing? And it will regenerate and update it. And this is a really fantastic tool for just making sort of little experimental throwaway applications. I use this all the time. It's great. And what surprised me, again, when I investigated this, was the main secret source to this is actually just a prompt. So it's just something that they tack onto the system prompt to make it understand and be able to use artifacts. And that prompt is really, really big. This was my first experience of seeing like I guess a production prompt that is required when you're going to be putting a tool based on an LLM in front of tons of people, some of whom will be actively trying to subvert what you're doing, and some of whom will just be dumb, and some of whom will be trying things that never occurred to you. And you need the LLM to stay on track in all those kind of different cases. And that prompt is massive. It's like 3,000 words. It's about 10 pages of code when I skipped through it. And what was really crazy to me was that it has complete examples of conversations in there. So, you know, the user said this, and the assistant replied this, and then it used this artifact, and this was its justification for using the artifact. And then the next time, oh, I'm going to reuse the same artifact because it met this, and this criteria. So it's like 4,500 tokens out of your 200K total, which is, I mean, it's a little bit, but it's, and you have to send that every time you send this back, right? So most of the LLM providers now have like caching systems so that if the bit at the beginning of the context window remains constant, then it will be cached, and because you pay for these tokens every time you make a request to the API. So the caching helps reduce that, but it adds another level of complexity to the management of the context. And you might have heard the term of prompt engineering, which you know, a couple of years ago was this kind of snake oily sort of career path, basically, which was basically people who had played around a lot with LLMs, figuring out like the magic incantations that you needed to use to actually get them to do things. There's actually much less black magic in it these days as the models have just gotten better, and you're just better off to just be really clear and explicit about what you want. They're really good at following if-then-else logic, so you can say, you know, if you see this thing, then you do it this way. If you see that thing, you do it this way. And while you're doing that, if you see this case, then you do this. And if you see that case, you do that. And lots of examples in the prompt. It works really well. So, you know, I'm working in Clojure, and I'm only just talking to an API. It's just JSON over HTTP, so I set it up in my REPL. In this case, I want to access the index information that is in my project from IntelliJ. So I'm using a REPL that's actually open on my IDE instance, and this is something that anyone who's hacked on eLisp has done. You have a REPL on your open editor, and you can play around with it. In this case, I'm mostly using it just to access the APIs that allow me to get the information about the structure of the project. And then I call the Anthropic API. Claude 3.5 Sonnet is still the best model for coding. And I'm building the context using the data that's passed in from a REPL command, basically. So, and then I use the APIs to dynamically build the context that is relevant to translating that specific piece of code. And I template the prompts using James Reeves' Comb library. So you don't need to worry about all the details here. This is setting up a REPL command inside of Cursive. And all it basically does is it will call this translate file var in the Cursive LLM commands namespace. And what that does is it gives me an action in the IDE. I can bind it to a key. I can use it in this is called a quick list, a little pop-up menu of frequently used commands. So I just have one key binding that pops it up, and then I can select the one I want. So I have this one, translate namespace to Kotlin. And it will go, and again, all that really does is evaluate some code in my REPL, which is running in my IDE. And so what it will do is it will go away and it will find all the vars in the file, and it will find all the dependencies of those vars. So which vars does this code use? Which classes does it use? Which methods on those classes does it use? Which of those references are to things which exist in my project, and which of those references are to things which come from my dependencies, either from libraries, from the JDK, whatever else. And I can figure out all the dependencies between all the vars transitively, basically. And I can use the dependency information to figure out what I need to put in the prompt. So when I write Kotlin these days, my Kotlin code actually looks very similar to Clojure code. So it's all top-level functions. Everything's immutable as much as I can make it. And I have a port of transducers that I use in Kotlin, because for a lot of use cases, transducers are just really nice. So I can detect, based on all this dependency information, this code that's being translated uses transducers. And I can add a little chunk to the prompt that says, this code uses transducers. There's a port of the transducer API in this file over here. Here's the API spec for it. And I can automatically generate, using the IntelliJ functionality, basically an API spec, which is the signatures of all the functions that are available in that API. Similarly, often I have a namespace that will use a utility namespace that I've already ported. And so I can detect those cases, and I can say, hey, you're using the cursive.names namespace, and that's already been migrated to Kotlin, and the API is over here, and this is what the API looks like. And you can get very specific. You can say, if you see the use of this function, then you translate it in this way. And this specific, kind of very case-specific stuff is what I think will be really useful for Clojure Dart, because depending on the Flutter features you see the code using, you'll be able to say you translate it into Clojure Dart that looks like this. And I can get, any dependencies that the code is using, I can just get the API information straight out of IntelliJ. And those summaries are automatically created. It's not something that I have to be maintaining by hand in my prompts. And then I just generate a detailed prompt using all of that. Lots of if-then cases for all of these cases, depending on what I found. I can add the source code of the vars that are directly referenced from that, so that the LLM can see what this call and the code that's being translated is actually doing. API specs for the interop methods or function signatures, and all of this is specific to the code that I'm translating. So the artifacts prompt that we were talking about before is about 399 lines and about 4,500 tokens. I generate a prompt from this for a particular file that I just looked at while I was preparing this talk. It's 1,500 lines and 14,000 tokens. So it's significantly larger even than the artifacts prompt. So these prompts get really, really big. But the LLM it stays on track with all of that. And so this was about the time at which I proposed this talk, right? It was all going really well. I was working in the REPL. It was all fantastic. The results I was getting were really good. I was like, this is cool. Everybody should be doing this. So I proposed the talk because the deadline came up. And not long after that, I started trying to use this for more different things. And I started coming up against some of the problems in the way I was doing it. And I started realizing that actually integrating this into your editor rather than doing it purely through the REPL is actually really helpful. And it's mostly around being able to refine the results that you get back from the LLM. So the LLMs almost never get it right first time. So they return you a result, and you look at what they've done, you're like, hey, that's not right. This bit over here that you did like this, you need to do it like that. And so initially, my very first version of this would translate a file, and it would just spit the translation out into my REPL on standard out, and I would cut and paste it from there and put it in a file, which obviously was not going to be very sustainable. So I added another little command, and again, this is just a command that sends some text to the REPL, but because my REPL is running in my IDE, I can set up a little bit of UI, and it pops up this little thing, and I can enter the prompt. And I could just use readline in the REPL, but often you want to enter a lot more than just a line, and so having like multi-line editing in the REPL, it's possible, but it's just a little bit tricky, basically. So I had this button that popped up, and that sort of got me a bit further, but anyone who's even slightly interested in ergonomics can see that this is not a great experience either. So whenever anyone integrates AI into an editor, the first thing they always do is they do the fancy autocomplete, where you can have what you want in a comment, and then you start typing under it, and it spits out a big chunk of code. So this is what Google Copilot did for the longest time, basically. This was pretty much all it did. And that's always the first thing I turn off in any of these tools, basically, because I find it's wrong as often as it's right. And when it's wrong, it's really pretty annoying. I don't know if it's just the JetBrains implementation, but it will like pump out a bunch of code that I didn't want it to, and then I have to go back and delete it, and it was just annoying. It's occasionally like really magical when it works, right? I type two things and it pumps out a whole bunch of code, and it's exactly what I would have written. I'm like, I feel so seen. That's great. Although it probably just means I'm very predictable, right? So I skipped that step, and I went straight to a UI for having larger chat-based changes. And so now, when I run, I've now added, this is not actually in Cursive, this is actually a separate plugin, but in IntelliJ. So now I have this chat window, a fairly standard kind of UI for these things on the right-hand side there. And so now, when I build up this enormous prompt, that gets put into this chat window as if I'd like laboriously gone through and typed out 15,000 lines by hand. And then the reply from the LLM comes back, and on the left is the translated code that it's produced. And if you look at the top of that code there's a little bit of UI that says 1 out of 1, and there are some arrows there. So what I actually did was I actually implemented artifacts in the editor, the same as the Claude artifacts from the website, and I used basically exactly the same prompt that they use. And I just need a little bit of stuff on this end to get back what it provided me, to put it in a scratch file, and then when it iterates on it, you get different versions, and you can skip through them with the arrow keys and diff them and whatnot. And this is actually a pretty nice user experience, and this got me reasonably far. And for the actual code translation use case, my specific use case, this is about as far as I took it. And there are different ways that you can refine the results. Sometimes you don't necessarily want to have to go back and type a big message about what went wrong. There are different types of refinements that it's nice to have quick ways to do it. So IntelliJ is famous for having little red squigglies in the editor when it doesn't like things that you've done. So refine using problems from file will actually take those inspections and send them to the LLM saying, hey, in the editor, this code, the editor is complaining about this bit here. So it'll take the line that the highlight is on, and it'll send a couple of lines from either side of that as some context. And it can send a whole bunch of those at once. If you've got like 20 errors in your file, you send them all to the LLM and say, hey, fix this, and then it will come back with the next iteration. And obviously, if you're using Clojure code, you might want to actually refine with the results from the REPL. So say it sent you some code, you evaluate it in the REPL, you got an error. It's easy to fish that error out of the REPL, and you can just send it straight back to the LLM and say, I got this error, what's up with that? And similarly, you can do that with just the output of the last evaluation in the REPL. And this might be maybe you executed some tests and some of the tests failed, and you have the test failures there, and it will send them off, and those, and it'll have a go at fixing them. It may or may not. And so there are a bunch of different sources for this iteration. And some of the AI, you might have seen AI coding products now that will actually do this automatically. So it will go out, you give it a task, it will go out to the LLM. If it finds an error or somehow fails in some way, it will automatically send it back and just have the thing in a loop trying to fix it. So you can get feedback from your editor, you might get feedback from your compiler if you're using some sort of compiler language, you get feedback from your REPL if you're using like a REPL language. So one thing I implemented that was quite fun was LLMs are actually surprisingly good at reviewing code. They're probably better at reviewing code than they are at writing it, actually. And so I made a little action that would take the first message from the conversation, which was usually this huge message that I generated, and I used that sort of as the specification for what should have been done. And then I got the last version of the artifact that had been produced in that conversation, and I sent the two of them off to the LLM saying, hey, here's the spec and here's what the result was. Do you see any problems with this? Anything that should be fixed? And it will produce a bunch of suggestions, which you can then give back to the LLM in the first conversation and say, hey, how about you do something with these suggestions? And I had a lot of fun there, actually getting OpenAI and Anthropic to review each other's code. That was kind of fun. And you can also attach visual feedback these days, like the vision models are getting much, much better. So you can just take a screenshot and you can say, hey, look, it's red over here, and it shouldn't be, it should be red over there instead. And they're actually getting very good at using those as well. And I haven't actually tried this, but I have a feeling that structure feedback might actually be really useful as well. You can imagine this if you were doing something on the web and it's not quite looking how you would like. It might be difficult to tell from a screenshot what is actually going on, but you could actually fairly trivially from the browser just get the whole DOM out and send it over and say, look, here's the DOM, what's going on with that? And for my cases working on Cursive, I could do that with the swing componentry as well. And so what I found was that there were pros and cons to just working in the REPL with this stuff. And in my case, I think I got further before I realized how difficult this was, because my case is kind of special, right? My application is the editor, right? So my REPL was on the IDE, and so my editor and my application are the same thing. But if you actually try separating this out into a standard use case where you have your editor, you have your project, and then your application runs in a separate process, you have a REPL on that process, and then you start needing to get some feedback from that REPL, but also some feedback from the other REPL and combining it, and it's actually very difficult to do in a way that's ergonomic and easily controllable by the user and also evident to the user what's actually happening. And this is why I start thinking the editor integration of these tools is actually really essential. Again, I'm kind of biased, like you would expect me to think that, but my experience also tells me that I think that's actually the way this thing needs to go. And that's harder once your application is actually separate from the main application running. Running in the REPL, I think there are a few use cases that it does work really well for. It works well for cases where you don't need that kind of iteration. So you might have seen that things are getting really popular. There's sort of agentic workflows now where the LLMs will go off and try and perform tasks independently, and then based on those results, I might call another LLM to do something else. There's kind of orchestration workflows. I think the REPL would work really nicely for those. And they're also good for tasks like my translation task, where you have a really clear upfront specification of what you want to do. And so my use cases kind of progressed on from just the translation thing, and I started trying to use this for more things, and I ended up integrating this more deeply into the editor. I am not brave enough to demo a live LLM thing over conference Wi-Fi with just like a capricious non-deterministic thing on the other end. So instead, I'm just going to show you a video of kind of what I've ended up with. So again, on the right-hand side, there's the chat panel. There's a combo box at the top, general software development chat with diffs, and that's just setting the system prompt. So this is saying, this is what we're going to be using this chat for. And under that, there's the name of a file. And that's a file that I've just added to this chat for context, so the LLM knows what we're talking about. So in this case, we're just going to be working on a single file. That file is what you can see on the left there. And this is actually code from Cursive. So this is my test suite for the paredit implementation in cursive. And so I can add that context in one of several ways. I can add it just as read-only context that the thing can use kind of for reference. I can make it writable so that it can update it, or I can just have one of these automatically generated API summaries. And that can either be a specific file, or it can be a directory. So I can send the whole directory over there, and it will generate an API summary of everything under there. So then I can just ask it, this is my test suite for the paredit implementation, which it kind of knows what it should be like. Please identify some edge cases I haven't thought of yet. And it generates a little bit. And again, I'm not going to go through all of this in detail. You'll just have to believe me. It actually does a pretty decent job of identifying things that might be tricky edge cases, and in particular ones that I haven't captured. And it proposes a change. And it actually proposes a change for this test we have open here in the editor. So looking at it, just eyeballing it, I can immediately see that the actual test on the left has them inside this doSeek block, and that's because it's testing for multiple carets, that everything works with multiple carets. So I'm going to reject that change because the test it proposed isn't doing that, and I'm going to say, please put these changes inside the doSeek and use multiple like the rest of the tests do. And again, it goes away and thinks about it for a little bit. So would you like me to propose more test cases? We're not going to do that just yet. So I can have a look, and this actually looks pretty, pretty okay. Again, I'm not going to go through, if this was actually me doing my job, I would go through and check that the test cases make sense, and I would run them to make sure they work and so on. But I can just click apply there, and it applies it in my editor. And you can see, it's actually done a pretty good job of matching the tests that are there already. And when you think about it, this is quite a tricky test for the LLM, right? Because in paredit, the indentation of both the source and the results is really important to get right. So the tests actually have to be in text. I can't just be sending Clojure forms over and operating on them. So these are tests that are taking Clojure forms out of text. They're putting them into a virtual editor inside IntelliJ. They're executing actions on them, and then they're taking the text of those results back and checking to see whether it matches. And it's able to work that out, and it actually does like a pretty bang-up job on that. I'm pretty impressed. So the next level of editor integration is not just working on single files. So they're mostly pretty good these days, actually working on single files, and the next big step is having them work on larger multi-file changes. And I'm not going to make you sit through a video for that, but I actually, so the other day, there's a new tutorial for standing up an HTTP, like a website basically, with Clojure. It's called the Caveman tutorial, and it's just like a step-by-step tutorial. Okay, you go through and you do this. And I went through and I used this tool to implement the tutorial. I went about halfway through. I got as far as the point where you have to stand up a database, and I didn't want to go there just for what I was doing. But so this is available on my GitHub. 100% of the code was written by Claude. So you can check it out and see what you think. The code is pretty simple. It is a tutorial, but there's also a link in the description. There's a link to the full transcript of the conversation, so you can see how it went. You can see the diffs it proposed, and I think it's quite interesting to look at. And in that, it actually did a pretty good job at, in a single response, making changes to multiple files, and occasionally it proposed up to kind of 8 changes in a single response, and they were all pretty consistent. So where do I think this is kind of going from here? So current LLMs are actually getting pretty good at small local changes. They're not perfect, like you still have to iterate a lot, and part of the art of using these things is recognizing when the thing is just getting stuck and getting in a loop, and you just have to give up and do it yourself, and then you can continue from there. But for small local changes, just change this function to do this thing, or change this file in this way, they're getting pretty good at those changes now. They're still pretty subpar at larger repo-wide changes, and I think where this is kind of going is having better specs and planning around these things. And what I mean by that is that the sort of next level of kind of modality for interaction with these things, I think there's a good example of it. There's a thing called GitHub Workspace, and this is not actually fully public yet. You have to apply to get access to it, and I just got access to it the other day. And the way this works is that on your repo, so this isn't something that integrates with your editor, I don't think. It's just in the GitHub UI. So you would start from an issue that you have in GitHub, and there's a button there, open it in a workspace, and you would open it, and it analyzes the code in the repo, and it analyzes the issue, and then it makes a specification for what it thinks the change is that you should make. So it has a list of the current state that it thinks is of the project that's relevant to this change, and then it has a list of the proposed state of how, what the world should be like after we've made this change. This is kind of like your acceptance criteria, right? And both of these are editable if you find that it hasn't understood what you were trying to communicate in the issue, or it's missed some information, or it just didn't have the information because you weren't specific enough in the issue. You can go through and edit it, and you can also edit what the proposed criteria at the end should be. And then you can generate a plan, and the plan sort of looks like this. Okay, in this file, I'm going to make this change. And again, you can edit these if you want to. And I just got access to this the other day. I have not had great results with it yet. Again, I've been trying to use it for Clojure code, which the LLMs do not work as well with as other languages. And I also suspect that my issues were just not detailed enough, because they were pretty much just kind of mental notes to myself about what needed to happen. So it was very, very far short of a useful specification. So at some point, I'm going to sit down and actually write those out a bit more fully and see if I can actually get it to work in a useful way with it. And that, I think, is probably where the next level of AI tooling will be, is having detailed specs and plans for the changes that have happened in the repo, actually in the repo, so that the LLM can access them. And I know the ex-Cognitech, now Nubank guys, that this has always been a big part of their development flow, is having plans and specs and details about how their thinking has evolved over the course of a change. And that information, it's useful for new humans coming to the project, but it's also useful for LLMs. And I suspect that it kind of seems like, so Donald Knuth, decades ago, proposed this thing called literate programming, and the idea was that you would interleave code with natural language specifications of what that code should be like. And there have been various attempts to do this, and I don't think anyone has ever really nailed it. I've never seen anyone use it for anything real. But it's kind of an interesting idea, and the problem, I think, has always been keeping the text specification in sync with the code, because you edit the code and you forget to update the text. So maybe, before too long, we'll actually just be editing the text, and the machine will update the code, and it will always be in sync. So there's a whole series of uncomfortable questions for various people around here. There are some uncomfortable questions for me as a tool developer, right? How much time should I spend polishing little low-level code manipulations in my editor, right? Should I spend a lot of time working on my Paredit implementation? Because I can see, potentially, before too long, people might not actually be making those small changes themselves. Similarly with refactorings. Refactorings will probably be around longer because they're larger multi-file changes that the LLMs are currently not great at. But I can imagine it's very hard to know how far and how fast this will go. I can imagine a point where that might not work that well either. It seems like code indexing will become even more important than it already is, so that from changes you can identify which parts of the code base are likely to be affected by a particular change and retrieve information about those in flexible ways. So I think that is definitely going to be a lot of work in my future. And there's a very real chance that developer tools in 1, 2, 5 years might look extremely different to how they look now. And I don't think anyone really knows what they will actually look like. We're all just kind of playing around at the moment. And there are awkward questions for developers as well. I was actually having dinner, I think the night before the conj at a restaurant in town, and I was just eating at the bar because I was on my own, and the waiter came up and he said, "So what do you do?" And I said, I'm a software developer. And he's like, "Oh my God, I'm at Virginia Tech and I'm 2 years into my degree. Am I going to have a job when I finish? And I need a job to stay in the country." And I'm like, well, quite apart from AI, I think it's a difficult time to be a new grad right now. I don't think AI is going to take anyone's jobs in the 2-year time frame, but far beyond that, who knows? But I do think there's also a question of what our jobs are actually going to look like. And there was, again, this is probably a little small for you all to read, and I don't expect you all to read it, but as a summary, it's a post on Reddit from about a year ago by someone working as a 3D artist in a small game company. And what they're saying is that overnight, that with Midjourney getting better, their job changed into something that was just completely unrecognizable to them. So this is not someone who lost their job, right? But it's someone whose job, over an extremely short time span, became something that was not what they signed up for, right? It seems like they really took a lot of care. They really felt like they had quite a sort of artisan touch with the work that they were doing. And now they're just like prompting Midjourney to do things. And he said, like, you know, I have no choice. My boss has no choice, right? I can do in 2 days what used to take me weeks, right? So I'd be stupid not to do it, but the part that I loved about my job is gone. And I think there are some tricky questions there for Clojure developers as well. Like, it's unclear to me how, if this really is the future of the way things are going, it's unclear to me how much more expressive languages really, you know, how much are they going to help? Because a lot of the affordances that they provide are there to make things easier for humans. And if it's not the humans doing it, maybe we need to start thinking about our programming languages being optimized for LLMs. I don't know. So, I mean, I already pick a language not just based on the language itself, but on the tooling, the libraries, the ecosystem around it. And so now, say I'm starting a company and I have a completely greenfield project. I'm totally convinced that this AI tooling is going to be really beneficial. I'm probably going to be picking a language that I know works well with LLMs, right? And for Clojure, lack of training data is a real issue. There just is not as much Clojure code out there as there are other languages like Python. There's tons of it. And also types and surface syntax really help. Like, maybe we'll all be like working on startups that are in Java, and you know, there's a reason that Java was actually developed for really large teams. It's very, very easy to pick up some Java code and see what it does, which means it's very, very easy for an LLM to also understand what it's doing and modify it. I do think that Cursive and Condo being like static analysis tools that actually work on the source code, I do think they've actually been gently nudging the community towards code where the intent is actually more visible in the source and not hidden behind kind of runtime craziness. I think as a community, we've kind of moved away from that a bit, not as much as you would see in like Scheme or Common Lisp or something like that. And that will help, I think. So I wanted to end with a couple of quotes. This one is from a comedian called Louis C.K., and it's quite an old, he has this fantastic sketch called Everything is Amazing and Nobody is Happy. Right? And he talks about how amazing everything is, but how quickly we get used to that and how cynical everyone is, right? And I see this a lot with LLMs as well. Like, you see some amazing thing and someone in some post on Hacker News or somewhere says, yeah, you know, it is great, but can it, you know, reliably add 2 numbers, or can it tell me the number of R's in strawberry? And I'm like, did you see what it just did? You know, and so I try to kind of maintain a bit of that sense of wonder with it, because I mean, I've been working with computers for longer than I care to admit, right? And in the last 6 months, I've had more experiences of, that's incredible. I cannot believe that just worked. You know, it is amazing what computers can do. And a lot of us have probably seen this quote as well. This is from the preface to SICP. And again, I'm not going to read the whole thing, but it talks about how we should keep the fun in computing, right? We should be stretching computers, seeing what they can do, and trying to keep a bit of a sort of playful, fun attitude to it. And so 2 weeks ago, I was on vacation with my family. We were in a camper van in Switzerland, and I was checking my email in the evening, and by chance I saw a video that someone had uploaded of their 8-year-old daughter implementing a Harry Potter chatbot using Cursor, which is an AI-focused IDE. So I have a daughter who's 10 and a half. She's a bit older. She's not at all into programming, but she's really into Harry Potter. And she was like, wow, that's cool. We should do that, right? So I downloaded Cursor, and I shepherded her a little bit, really very little. Like, the main help she needed was just around setting up OpenAI keys, which is kind of tricky, right? But in like 20 minutes, She was chatting with Harry Potter in something that she had built, right? And I know that LLMs have all sorts of problems that I just haven't had time to deal with here. There's all sorts of ethical problems about the provenance of the training data. There's all sorts of potential social upheaval problems due to job displacement. There's all sorts of ecological problems based on their energy use. All of that is true, and I'm totally aware of all of that. But that moment with my daughter, where she got to do that and the feeling that that gave her, that was just magic. Thank you.